I am at the Old Barn Creamery in Holtwood, Pennsylvania, in Amish country. And we are at this project installing quite the system. So we've got 28 panels on the roof for a total of 7 kilowatts. A brand new weatherhead, brand new service. Panel disconnect out here, which is our main ground bond and our first disconnect of the system. And the solar coming from the roof down into the building. Before we go into the mechanical room, come around the outside. Look at this beautiful property. And come around the corner, and we have a generator room. And in the generator room, it's all vented out. And the generator runs to this panel here. This panel and the call to start then goes, and we haven't run it yet, but it gets MC through to the downstairs, because we have a unit that will call to start this generator when the voltage of the system drops to a certain parameter level. I'll explain that in just a second as we come around the corner. So FDA says that by law they need to have an electrical service, 200 amps for the creamery, milk products, things like that, walk-in freezers, but they'd like to run off-grid as much as possible. So down in the basement, we have the original 200 amp service that we have now changed into this on-off-on bypass. The on-off-on bypass right now is on grid, so these panels are all being powered by the service right now until we're finished our install. But out of this service, we have 4-aught SER 200 amp into our main 200 amp blade fuse. Let me get this open. So we have 4-aught coming in through the blade fuse, which is our disconnect. Then from there, it's bugged out into 2 even 100 amp SER lines to both of these gigantic inverters. Evenly split. So what happens is this will be our grid input coming into the machines. We have CT meters that are on the main lugs in here, up there on the bugs, and they make sure that these machines do not pass any power back to the power company. It's called zero export. So this will be our last resort grid. These machines are going to take the PV from the roof and possibly other arrays in the future, and it's going to use them for all of the loads. It's going to split the 200 amp service into even 100 amps per machine. We have 3 16 kilowatt hour 300 amp PV modules, freshly built, beautiful Wi-Fi, ready to go. 1000 amp DC bus bars, all with pure copper welding wire, 2-aught and 2-aught connections. These machines can take 250 amps each, so they have dual 2-aught leads coming up with ferrule connections into the battery breakers, which is in that machine there. And then you can see over here in this machine, there's your dual feed from the battery bank. So we can pull 500 amps DC from this system. And then they're both in parallel, they're both sharing current loads. The generator you saw was not in the generator port here. We did not choose to use that option. We're using the new charge verters. They're 100 amp charge verters. They get plugged in. This is where the generator outside comes into. And then these two units call it to start. It starts up and converts the 240 directly into DC and gets pumped into the DC bus bars and into the batteries. So it's basically like making sure that the generator is acting like solar panels, and it just comes directly into the batteries. That way the machines can just pull DC and convert into AC and run all the loads seamlessly. It's a pretty big system. It's full bypass. Very neat, very clean, and we're about to commission it. So there it is. Just a really, really big system. Guys, have a nice day.